All right, proceeding to the next part of our solution in question 1. So as you can see, the next part is that we have been asked to find the number of moles of hydrogen ion in 250 cm cube of A. Now recall that for A, we have already deduced the concentration, which is 0.102 mole per dm cube. And if you recall, the question I just said earlier now is in 250 cm cube of A. That simply means that the volume of A in this part is 250 centimeter cube. So when you have concentration and volume in this format, I believe it is the easiest thing to convert it to mole. And how do you do that? By using the formula. The formula is N is equals to CV over 1000. So that's 0.102 multiplied by 250 divided by 1000. So if you do that, our mole should give us 0.0255 mole of A. Now, I've always highlighted the fact that your answer should be in 3SF, 3 significant figures for you to score. So that means your answer should be 0.255, not 25. So that is the mole of A. Now, if you look at A, from the idea of what we have about A, H2Y. H2Y is very synonymous to H2SO4. And when H2SO4, when it ionizes, you're going to get 2 hydrogen ion plus SO4 2 minus. So in this same breath, we can look at H2Y. When H2Y ionizes, to give us 2H plus and Y2 minus. That means that the mole for comparing A and hydrogen will be 1 to 2. That means you have a coefficient of 1 attached to H2Y and a coefficient of 2 attached to H plus. So that will affect the mole. It simply means that if the mole of H2Y is 0.0255, the mole of hydrogen ion will be 2 times 0.0255, and that should be 0.0510 mole of hydrogen ion. So now we have gotten the number of mole of hydrogen ion in 250 cm cube of A. Now, if you proceed to find the number of mole of hydrogen ion in 1 dm cube of A, which is the next question, again, we realize that the conc of A is what? 0.102 mole per dm cube. That statement simply means that in 1 dm cube of A, the mole that is there is 0.102 mole. Then let us proceed to write the equation for how it ionizes again, although it is there, but for clarity purpose, we need to write it once more. So H2Y, if H2Y should ionize, we are going to have H plus, 2 of it, 2H plus, and then Y with a charge of 2 minus. So comparing the relationship between H2Y and H plus, you can see that 2 moles of H2Y would produce, you can see that 1 mole of H2Y would produce 2 moles of H plus. So that means if the mole of H2Y is 0.102, the mole of H plus will be 2 times 0.102. So that will give us 0.204 mole of hydrogen ion. So it simply means we have derived the number of mole of hydrogen ion in 1 dm cube of A. So how do we find the number of ions? Number of ions is quite simple. Number of ions is equals to number of mole times an Avogadro's constant, which is 6.02 times 10 to the power 23. So we proceed by using the formula. Therefore, my number of hydrogen ions in 1 dm cube of A will be equals to 0.204 multiplied by 6.02 times 10 to the power 23. So that should give us 1.23 times 10 to the power 23 ions. So that's the solution for question 1.